All right. So thank you, Natalie, for introduction. And guys, I'm really happy how the conference is going. Very good presentations from our users, good presentations from AnyLogic, kind of lot of good reactions. So really happy. So here in this presentation, I'm not one of the authors, and I'm here only to once again introduce Nikolai and Dmitry, and I'll do just one slide about AnyLogic. So Nikolai, the person who you probably have known for years, is our principal software engineer, and he knows everything about our product. And Dmitry is the team lead for AnyLogic core and libraries, which means that basically everything that you use in the desktop application, all libraries, AnyLogic engine, animation, Omniverse integration, etc., is developed with the leadership of Dmitry Alikov. But our topic today is our R&D. And actually, this is the first time we're disclosing and showing some of our AI-related R&D. So the AI with the model and the modeler, exploring integration for simulation co-design. Dmitry, Nikolai, please.
Thank you, Andrei. Hello, everybody. Today's agenda. AI and machine learning have gone through several waves of hype over the years. Naturally, we explored how AnyLogic could connect with these technologies. So today, we'll briefly mention the LLM. LLM is a large language model, so this pre-LLM stuff. And then we'll focus on how we are researching the ways LLMs can support AnyLogic model. Okay, this early machine learning era, the before LLM era, the early machine learning needed massive amounts of data to train. That's where the simulation fit in, providing synthetic data, especially useful when the real data, historical data, was insufficient. Then reinforcement learning came into the spotlight, and AnyLogic already supports these data elements, connectivity, dedicated RL, reinforcement learning experiment type, and integration with Python, of course, with access to all the well-known AI libraries. That's still relevant, but the adoption hasn't spread widely, mainly because of the complexity. And finally, if you scan this QR code, it'll take you to a special section on our website. There you'll find detailed use cases, example models, information about the libraries. We use videos and other helpful materials. It's a good starting point if you'd like to dive deeper into this topic. Okay, now the LLM era. So Andrei.
Yes, thank you, Nikolai. So, and at this point, everything gets more interesting, more exciting. So let's see how LLM, let's say, interacts with simulation industry, so to say. So this is what is happening now. We have this is the way I managed to draw an AnyLogic user. Happy guy. Okay, so he's interacting with AnyLogic user interface, of course, but at the same time, he's might use LLM, and this is already happening. LLM is used obviously in as another application. This is what AnyLogic users are using it currently, like today. This is already happening. So first of all, of course, like some logic coding, like writing these Java snippets. How do I, in this particular box, make, for example, close this valve under that certain condition. And LLM can help you with that. Now, debugging, of course, okay, I'm getting this error message. Could you suggest what the error could be? Okay. Experiment planning, parameters, experiment setup, like variation, Monte Carlo, etc., etc., and of course, analysis of the massive output data that simulation produces. This is now. Now let's look at the near future. Now the change is that AI and in particular LLM from optional helper moves to integrated productivity tool, so that the user won't need two different interfaces. The user will not need, to type in everything and to provide LLM the context. And Nikolai, can you click once again, please? This is the possible things that LLM could help you with. Of course, conceptualization, like create initial draft of the model. Same thing, logic coding, write some code snippets. Then automating routine work, like, okay, I have a CAD drawing or I have an image, and then, okay, how do I create like a railroad network or AnyLogic, other type of AnyLogic markup like transporter routes or road traffic routes. And then same again, debugging, experiment planning, output analysis, model improvement. Okay, here's my model. It works, but I want to change it. What do I do? What are your suggestions? And finally, exploring a model. Okay, this is probably, let's say, mine or somebody else's model. It's complicated. Please explain me how it works, what's inside. Okay, so these are just some possible ways LLM can help us as modelers. And Nikolai, next click. This is the areas of our current ongoing R&D. And some of that we will demo you today. But that, of course, is not it. So there's possible future, which is again different. And Nikolai, one more click. Stay with us. We will talk about it at the end of this presentation. Thank you, Nikolai.
Thank you, Andrei. So we've been experimenting with these technologies, and now we'd like to share some of the research results with you. For this, we used a modeler, this guy, an LM, and a special build of AnyLogic with design time scripting through the Python API. Just a couple hours ago, in the AnyLogic 8 roadmap presentation, Anastasia showed the upcoming Python API for space markup designed to build converters from CAD files and other data sources. Here, though, we are using an extended version that can also generate full model logic, flowcharts, statecharts, parameters, and more, and you'll see this later. So the AI, given a request, could generate a script that builds a model. In our research, we used GPT-5 from OpenAI together with Cursor AI as the AI assistant IDE. Cursor integrates LLM prompting directly into the development workflow, making it easy for us to send prompts and immediately run the Python code, which is generated by the LLM. Large language models are powerful, but they are not a magic wand. They need a bit of the time to think. Their answers can vary, and they do not know any logic perfectly right away. Yeah, they can search the web, but the best results came when we gave LLMs some supporting files and a carefully crafted prompt. And the result, the script that generated a model in AnyLogic plus a description of what it has had built. So you see here some flowchart, and you might be wondering what exactly are these Python API files. The API is basically a set of Python modules that mirror AnyLogic elements and their properties, letting you to create and modify them directly inside your model. Think of the API as a toolbox that the LLM uses to define and build the model in AnyLogic. The airport model requested by this guy was quite large and used several libraries, and for today's demo, we'll show something simpler. So now let's switch to video and show how AI can help and build simulation model from scratch. So I'll share the video now.
So in the first part of the video, we'll see how a model with a flowchart is created. Here is our example model, Trauma Center. It uses flowcharts to describe hospital operation. We will take this model description and use it as a prompt for the language model. Next, we open the cursor AI development environment and start preparing the request. We include the model description, also Python API files, then a file describing AnyLogic model elements, and a general prompt for the language model. The Python API defines classes for AnyLogic model elements with methods to get and set their properties. So you can see right now in the video. This build of the AnyLogic uses an extended API, so we can work with all model elements.
It's a pretty huge file.
We also provide a rule file, which is basically a general initial prompt describing how the language model should create the model. So it's quite complicated too. With all that prepared, we are ready to send the request to GPT-5. This part of the video is sped up 15 times since we are using a thinking language model. It produces better results, but takes longer. The output, now we're back to the normal speed, and the output is a Python script that builds a model with the AnyLogic API plus a short description of what is created. Back in AnyLogic, we start with empty AI model. We adjust model name and the script, and we are ready to run it. We align the windows so you can watch the AnyLogic in action. So a few moments, and here we run the script. Blocks appear, connections are drawn, and now we will see that properties of certain blocks, like resource pool, service, and select output, have been customized by the script. So this model compiles without any issues, and it is ready to run. And once it's running, we will see flowchart in action and resource pools working. It is simple model, but it's fully functional. Next, we will return to the cursor AI and ask language model to explain the model workflow. We send GPT-5 request, and it will generate a text description based on the script it created. Now keep in mind that at this stage, there is no direct feedback from AnyLogic, so the explanation comes only from the code that was generated before. In the second part of the video, we'll move to the state chart. Here, our example model, state chart for choice of competing products. We'll again use its description as a prompt for the language model. Here we select it and copy, and then back in cursor AI, we provide the inputs. User prompt with the model description, Again, the Python API files. And the general prompt. Okay, and just like before, we speed up the video 15 times to show the process quickly. Once again, the language model analyzes the provided API files to identify the best elements for the problem described in the user prompt. And just like before, the AI generates a Python script together with a short description of what it does. So we're back to normal speed again. And now we see the script uses our Python API to create and arrange blocks. Now we go back to AnyLogic and once again start with an empty model. We enter its name into the script and run. Now the script begins creating elements. At first they all appear at the origin point, but then they will be arranged on the canvas. Here the statechart, it now looks just like the one in our original example model. Here you can see code expressions in the transition properties referencing the variables from our model. And once again, the model compiles without any issues, and we are run it, and we see the behavior. The customer chooses product A until it's out of stock, and then switches to the product B, so the model works. Now let's slightly open the door to what future AI-powered AnyLogic could look like. In this part of the video, we want to show what it could look like if AI were integrated directly in the AnyLogic, so we don't need a separate tool like Cursor AI or external LLM website. Here is the chat window. We enter the same request to the create trauma center model, along with the usual attachments, element descriptors, and a general prompt. The video now is shown in real time. This time we are using GPT-4o. It's faster, but not necessarily better. It generates a script, and we run it right inside AnyLogic. The model is built and it works. The LLM didn't create resource pools here, so a thinking model might have done a better job before, but the model still works and it's a solid starting concept to build on. Oh, that was our demo. And we're back to slides. Nikolai.
Okay, thank you, Dmitry. What have we seen so far? I can actually take a problem described in plain language and produce the first version of simulation model. We haven't go deep into areas like animation yet, but we've tried space markup, although we didn't show it today. Error correction looks promising too. LLMs are strong at writing and fixing the code, and clearly the AI knows Java, the base scripting language for AnyLogic models. The next R&D step is feeding the AI an existing model so it can spot and fix errors, tune parameters, and build new parts interactively based on user requests. So now let's return to the LLM plus simulation journey slide. Andrei, over to you.
Yeah, I can share my my screen if you want.
Okay.
So yeah, thank you, Nikolai and Dmitry. That was impressive. That was impressive. So I will yeah. Hopefully you can see my screen right now. All right, very good. So we have we went through what's happening now and our near future, and we disclosed some of our R&D. So what's the possible more distant future? And this is, by the way, this part of the slide is more discussion slide, because of course we don't know our distant future. So yes. In one of the possible distant futures is that AI will maybe become the primary and the only user interface. It may happen, it may not happen, but many say that is our future. So the journey of AI is, in case of simulation, is from optional helper to the integrated productivity tool to the primary interface. So you will be mainly interacting with LLM and asking it to do the job for you. So I'm highlighting here that we're not talking about any logic user. We're talking about the end user, right? Who wants the problem to be solved. So what does that mean, right? Does that mean that all other softwares that are non-AI, like, I don't know, Excel, SolidWorks, MATLAB, AnyLogic, will go away? Not at all. Up. So that only means that they will probably move. Again, this is all undefined. This is all may not happen. That they may move from what we see on our screens every day to what I call AI backyard. So based on the problem description, AI will then choose the right tool set. Let's say this is Excel and Tableau, or in some other case, that could be AnyLogic and maybe R and I don't know, IBM CPlex and Power BI, something like that, right? And then AI will decide, what they say now, it will orchestrate the suite of tools behind the scenes and transfer the problem description in natural language to a complete solution, end to end. So let's say, okay, the frequent example is like, okay, I want my taxes to be done, and then you talk to AI, and then AI, okay, this is your completed tax return, right? Yeah, that is kind of already happening, right? But the only problem here is, of course, trust. Let's say I am designing an airplane, right? And everybody loves these airplane examples because we fly airplanes and we want them to be safe. So, okay, design a new airplane, and SolidWorks I don't need. Okay, MATLAB I don't need. I just tell, okay, AI, please do that for me, and AI comes back with a certain, shape of the airplane with certain characteristics. So we need such and such engines, etc., etc. Okay, trust, right? So trust is the main thing. How can I make sure that everything was done correctly? How do I verify that, right? And again, this could not be just airplane. This could be my warehouse, my supply chain, etc., etc. So what I anticipate, if we go that way, human remains in the loop. What do we mean by that? The human remains in the loop. So I see it this way: that okay, I can let AI use put together a simulation model for me, but I don't want just to watch animation. I do want to look inside. What is inside the model? How it works? What is in there? I may want to improve the model myself. So, in that sense, those tools that are down there in the AI background may not, at least in the beginning, go away completely. Their user interface will stay. It just both AI and humans will work with them, and AI to me will be still a very intelligent assistant to humans. That is my view on things. And so what do we as the AnyLogic company what can we do to enable that optional feature? Well, this is very straightforward. We should cover AnyLogic with all of it. All AnyLogic must be covered with different APIs. We're already doing that, and you have noticed even in Nastya Zhelyeva presentation, and then again from Dmitry and Nikolai's presentation, that is already happening. This is one thing, and then providing as much context, as much learning materials for help materials to the LLM, so LLM can try to master our tools. Okay, and if you want to learn more about AI and simulation and why AI cannot be a replacement, not even to simulation, but even to a simple calculator, please scan this QR code. This is our recent webinar we did with Luigi Manca on simulation and AI. And I think with that said, do we have any more? We don't have any more slides. No, right? No. Okay, so I'll stop sharing, and I think we can do some questions and answers, right? So I remember there was one funny question. Why did we start doing a Python API? Was that for the purpose of using it with the LLMs? And I guess, Dmitry, it's not really. Not really. We wanted to do it anyway for our internal purpose in the first place. But
Yes.
I mean, it's immediately we realized that, okay, that is the way we can connect LLMs to AnyLogic. So, and we then added more and more to that API. Okay, there was other question, I think, somewhere. Who's your chosen LLM? So I'll let the guys answer that.
Yes.
I mean, what LLMs do we use and why?
So we've tried several LLMs, GPT-4o, O3, O4 Mini, DeepSeek, Claudia, Opus 4, and GPT-5 was released quite recently, and it performed quite well. And so we right now we haven't benchmarked between different LLMs. That's something for the next step. Right now, our focus is on exploring the interaction between LLMs and AnyLogic. So on this demo, that was LLM from OpenAI, GPT-5. Okay, more questions. Are we planning to create model context protocol to make LLMs able to interact with AnyLogic platform in near future?
The near future.
In near future, I guess not. So first, our focus is on the AI assist version. And after that, we'll consider opening the full API itself. Okay, and we have a paper. Not yet. We have no paper for now. Providing model fragments.
Yeah, I mean, I think we're running out of time. Can I just do one last question, because it's already time. So the question is, okay, so now everyone can become AnyLogic modeler easily. What profession do you recommend to take next? for someone who will be fired after the release of this feature. I don't think anyone will be fired with the release of this feature. I don't think that anyone can become a modeler, any logic modeler easily, because professional modeler is a very unique combination of skills that you guys have. It's a combination of really, technical skills, also people skills, data, etc., etc., etc. I personally do believe very much in technical education. So I think, with regards to where to send your kids, I would still recommend, okay, mathematics, computer science, fundamental physics, that sort of stuff, even though they might not be using directly those courses in the future. These things train your brain so much and so well that you will be able to handle anything, any kind of problem, because you will be able to keep in your head problems and systems of any complexity. So I don't think anyone will lose their job because of AI. No, we will just progress to the next level. And I guess we have to finish here. Thanks very much for watching.